Welcome back. This is Mr. Hassan's Maths channel. I'm now answering questions from this paper, the October 2024. This is the Statistics S1 paper from the Edexcel International A-Level exam. And I'm going to go through each question as a separate video. I'll save them in playlists. One playlist for the paper, this particular paper, and one playlist for the topic that the question is from. And I'm going to try and answer the questions in a way that students who have had minimal exposure to the topic and who need kind of like some support and help can hopefully benefit from this, rather than just quickly going through it as if I'm taking the exam myself. So I'm not going to just read through the mark stream. I'll try and explain some of the foundations behind the topic. So I'm going to start with question 1. It says the back-to-back stem and leaf diagram shows information about the running times of 31 action films and 31 comedy films. So both of them have 31 entries. So on this side you have the comedy films, okay, and on this side you have the action films. So these type of back-to-back stem and leaf diagrams, which are back-to-back, they basically compare two sets of data which are about similar kind of content, but in like the same time. Okay, so we're talking about action films and comedy films, and we're talking about the running times of these films. Okay, so the running times are given to the nearest minute, so how long these films last. So here, when you have a stem and leaf diagram, you have to know what the numbers are referring to, and that's where we have what's called the key. The key tells us exactly what these numbers mean. So the stem is this part here. This is the stem part in the middle, or the part before these numbers which are listed, right? So here that tells you that this means 90 minutes for action and 92 minutes for comedy, right? So the zero, the stem is the tens, and these numbers, which are called the leaves, they are the units. Okay, so this number, for example, refers to 10 tens, which is 100. So that's 106. Okay, the leaf will always have only one digit. The stem can have more than one digit, right? So this is like 12 tens, and that's 7. That'd be 127, for example. Okay, so that's how we can understand this stem and leaf diagram. On this side, this would be, for example, 128, okay, and so on. So understanding what the numbers are referring to is very important in this diagram. So here they've got the running totals. Well, not the running totals, so how many in each category. So in the 90s, there's 5 here, there's 1 here. In the hundreds, there's 6 here, and there's 0 here, and so on. So they've given you the count of each of those. And they also told us the total in each case is 31. If I add these numbers together, if I add the number of entries, it's 31 in both cases. Okay, so now write down the modal running time for these action films. So we're now looking at just the action films, and we're looking for the modal running time. The modal running time is the time that occurred the most often. So we can see here, what we're looking for is the numbers that repeat the most. And we can see that these 3 sevens that repeat, I don't think there's any other numbers here that repeat more than those 3 together. So these are referring to the number 137. There are 3 137s, and there's no other number that has the same number of occurrences on this amongst the action films. We're looking at the action films, not the comedy films. So we're going to say 137. All right, so you might make the mistake of choosing 127, but that's for the comedy films, and here they're asking for the action films, so be careful. Then it says some of the quartiles for these two distributions are shown in the table below. Find the value of A, B, and C. So A is the lower quartile of comedy films, and B is the median of action films, and C is the upper quartile of the comedy films. So to find let's start with the median for B. Okay, the median is the middle term. Okay, so this is for the action film. We're trying to find B first. The position of the median is given by the number of entries divided by 2, which is 31 divided by 2, which is 15.5. So whenever you have something like this, when we're dealing in this form, when we do n divided by 2, we're looking for the term which is basically, when you round up, you get the 16th term. Whenever there's an even number, an odd number of entries, there's always one number in the middle. Like if you have 5 entries, for example, there's one number in the middle, one term in the middle. And here we have an odd number of entries, so there's one number in the middle. How do you find that? Take the number of entries divided by 2. If it comes out as a decimal, round up to the next number. If it came out as a whole number, you take that entry and the next one, because that means there's an even number of entries and there's 2 numbers in the middle. But here we have to look for the 16th term. This doesn't tell us what the median is, it tells us where it is. So we've got to count up to the 16th term for the action films on this side. So here we can see the running totals. You have 1, okay, 1 plus 0 is 1. And then you got 1 plus 5 is 6. And you got 10 plus 6 is 16. So that must be the 16th term. That term is the 16th term, which is 129. And you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 129, don't write just the 9, it's 129 is, okay, so that's called Q2. Q2, which is B, which is 129. So we can say B is equal to 129. That's one of our answers. And we've also got to find the lower quartile for comedy and the upper quartile for comedy. Let me just make a bit more space here. So we've got to find the lower quartile and the upper quartile for the comedy films. So we've got to find A and C. So we're going to find the lower quartile, which is A. This is for the comedy films. To find the lower quartile, we take the number of terms divided by divided by 4. Because the lower quartile means the term which is not in the middle like the median, but 25% or 1/4 away along the terms as they are ordered in order of size. And these are in order of size, as we can see. Okay, so we're now looking at the comedy films. All right, and we're looking for the lower quartile. So we take n divided by 4. So n is, again, the same number 31, because both of them have 31 in them. So that's 31 divided by 4. Now we see what we get for this. So we get 31 divided by 4. Now that gives us 31, that gives 7.75. So again, if it comes out as a decimal, we round up to the next number, that's the 8th term. So I've got to look for the 8th term. So if I go to, if I count along, that's 5, okay, and then you're going to have 6, 7, 8. That is the 8th term. So it's going to be it's going to be 106. 106. That is the lower quartile. Okay, so that's the value of A. That's Q1, and that's for the comedy films. Okay, comedy films. Yeah. Okay, so that's going to be what did we say it was? 106. So Q1 equals A, which is 106. And to find the upper quartile, which is C here, we take 3 times n over 4. This should say n over 4, by the way, not 2. Why did I write 2 there? Sorry about that. That should say n over 4. And I did it correctly here. For some reason, I don't know why I wrote that. But 3n over 4. So we can take the 7.75 and multiply it by 3, basically, because it's 3/4, it's 3 times that. That gives us 23.25 again. So that's 3 times 7.75, which gives us, what did we say? 23.25. 23.25. So we go to the 24th term. So you always round up. Even if it comes down like this, you round up to the next number. So we're now looking for the 24th term. Okay, so we have here, we've got, that's 5, that's 11, that's 19, 5 plus 6. Okay, so then you have, that's 5 plus 6 is 11, 11 plus 8 is 19, 19 plus 11 is 30. So we need to look for the which term? We're looking for the 24th. So we got 19th, okay, 20th, 21st, 22nd, 23rd, 24th. So 20, 21, 22, 23, 24. So we're looking for the number 126. That's going to be 126. So we got Q3 for the comedy films, which is equal to C, which is 126. So you have your answers here. A is equal to 106. B is equal to 129 and C is equal to 126. So there's the answer to question number, I think that's part B. All right, now we're going to do part C. It says, for these action films, find to one decimal place the mean running times and the standard deviation of the running times. So the mean running time, now the mean is equal to the sum of x divided by the number of turns, which you already have the sum, so you don't have to add them together, which is 4016 over 31. That will be the mean running time for the action films. Okay. All right, so they gave us the information we need for that. So that's going to give us, so you have 4016 over 31. 31 entries. That gives us 129.54. Okay, so you say the mean is 129.54. They want to one decimal place, so 129.5. That's the mean running time. That's for part 1. And then part 2 says, find the standard deviation. Now the standard deviation, which is got this symbol here, is basically the square root of the mean of the squares minus the square of the mean. Okay, square root of this is called the variance. Okay, the variance is equal to the mean of the squares minus the square of the mean. Now the mean of the squares is basically the sum of the squares divided by the number of entries, and the square of the mean is basically the mean, which is this squared. Okay, so we can find this. We've got what we need here. It's going to be 525,056 divided by 31. That's the mean of the squares minus the square of the mean, which is this number here, 4016 over 31. That has to be squared, and all of this should be under the square root. So the standard deviation is going to be equal to, so we take square root of, and we have 525,056 over 31. That's the mean of the squares. Okay, it's already been squared and added. Minus the square of the mean. So we take the answer that we got just now and we square that. Minus the square of the mean. The answer we got before was this answer, which was 411. Always use the fraction. This is the exact value that we had before. When we press equals, it should give you the standard deviation, which is 12.430. 12.430. Continue on. So therefore we say the answer will be 12.4. Okay, to 3 decimal, or to 1 decimal place. Okay, so these are in minutes. We could write minutes here if we want. We could write minutes here if we want. Okay, that would be the answer. So remember, the standard deviation, the mean is the sum of all the entries. So it's like we've added all the entries for the action films, and we've added them all together, and we got the answer 4016. Okay, so we added all these numbers. So 90 plus 112 plus 114 plus 116 plus 1. Added all those entries together and divided by 31. That gave you the mean. And the standard deviation is a measure of how spread out the data is from the mean. So what you do is you find the mean of the squares. So you take the square of each entry. So 90 squared plus 112 squared plus 116 squared plus 118 squared and so on. And you add them together. That gives you the sum of these squares. So this is the sum of the squares of each of the entries. And then you divide that by the number of entries. That becomes the mean of the squares. The standard deviation is the square root of the mean of the squares minus the square of the mean. So that's how we get those answers there. And there's the answer to part 1 and 2 of C. And now we're going to go on to D. So it says one measure of skewness is found using mean minus mode over standard deviation. Evaluate this measure and describe the skewness for the running times of the action films. So for the action films, we had the following bits of data. The mean, okay, we just found it to be, was it for the action films that we just found it? Okay, was it for the action films? Yes, so the mean was 4016 over 31. So I'm going to keep it in its more exact form. 4016 over 31. And the mode, I think we worked that out as well. The mode for the action films was 137. That was for the action, yes. So the mode is 137. Okay, and the standard deviation we worked out to be, I'll write this in a more exact form, like 12.4300. 12.43 is okay. Okay, so what we can do here is we can say it's the mean, which is 4016 over 31, minus the mode, which is 137, over the standard deviation, which is 12.43. So I'm going to leave this answer in here because it's more exact. And I'm going to, so this is now my answer, key. So now I'm going to put this and another fraction bar. So 4016 over 31. Okay, and then minus 137. And then divided by answer, which is the last answer, which was the value of the standard deviation. Okay, and that gives us negative 0.5994. Negative 0.5994. Okay, so we can say negative 0.60. Okay, or maybe to 3SF because they didn't mention anything else. Negative 0.599. So we can see that the skewness has a negative skew. Why? Because it has negative skew. Why? Because it has a negative value for this measure of skewness. Okay, so there's the answer to part D. Okay, so for part E, it says comment on one difference between the distribution of the running times of these action films and the distribution of the running times of these comedy films. Okay, so state the values of any statistics you may have used to support your comment. So basically here, what we can say here is we can choose any one of the things that we can notice. Now, I guess the easiest thing for us to do is to deal with things that we have already basically calculated. Or we have been given. So we were given that the median of the comedy films was 117, and we calculated the median of the action films was 129 minutes. Okay, and we had the lower quartile of this is 106 for the comedy, and 126 for the comedy films, upper quartile. So we could compare, for example, the medians, and we could say on average, the action film have are longer. On average, they're longer. The running times is longer because the median for action films is greater. We could mention that. We could talk about the spread of the variation or the variation in the times of the action films as compared to the comedy films by working out the interquartile range. So we could add another column here or another row here, interquartile range, upper quartile minus lower quartile. Well, that's going to be 17. And here this is going to be 20. So we could say that the comedy films on average are more varied on their in the times that they run in general, because the interquartile range is longer. Okay, we could choose any of those kind of categories. I mean, personally, I would stick to comparing the median times. Okay, comparing the median times, because that's something that we've already calculated both of them, and we don't have to do any further calculations. And it's pretty obvious that the median, the action films on average, they last longer. Okay, they have a longer running time. So we could just mention that. Okay, the median, say Q2 for the action is how much? Q2 for the action was 129. And for the comedy was 117. So Q2 for action is 129, and Q2 for comedy is 117. Okay, so therefore you can say that the average running time for action movies, sorry about my handwriting here, it's going to fall. For action movies is greater than done that for comedy movies. So basically, they last longer on average. They last longer on average. They last longer. Okay, they're the longer lasting movie. Okay, so we can talk about that. We could talk about interquartile range. But I think talking about this is probably the best thing, easiest thing, because we've already got the values calculated. Okay, so that concludes question number 1 from this October 2024 S1 paper. Other questions from this paper can be found on the playlist, which will appear on the top right of the screen at the end of this video. Other questions from the topic of data display, stem and leaf diagrams, and data analysis can be found in the 2 playlists over here. You can subscribe to my channel by clicking on the link. Thank you for watching and see you soon.